Hello viewers, how are you all? Hope you are doing well. So today I have come with another interesting new video of our 3-dimensional geometry lecture series, lecture number 28. So today we will discuss the distance of a point from a plane. So here if we consider a point in the space, we are going to find the distance of this point from this plane. So as usual, first we understand the whole outline of this theory with the help of real life mathematical models. So now we are going to understand the whole concept with the real life mathematical models. So today I have considered these two things as the planes in three-dimensional space, and as usual this Gorilla tripod as our Cartesian coordinate system. This is x-axis, this is y-axis, and this is z-axis, and this is the origin. Now our objective today is to find the distance of a point in the space from a given plane. So we have to find this much distance, this distance from this point to this plane. So first we will imagine another plane, imaginary plane through this point like this. Suppose this plane is passing through this point and must parallel to this plane. Why we are taking parallel planes? Why we are considering parallel planes? That I will tell you shortly. So now, suppose equation of this plane is r vector dot n cap equal to d. That is the equation of a plane in normal form. What we have discussed in our previous lectures, maybe lecture number 20. Go through the playlist of my channel SSD capsules, then you can get it. Now, what is the significance of n cap? N cap is nothing but a unit normal vector to this plane. Normal vector means this vector, if it is n cap, then n cap must be perpendicular to this plane. And what is the significance of d in the equation of this plane? D is nothing but the distance of this plane from this origin. So this much distance is d. Now, we have considered these two planes are parallel, right? Why? If they are parallel, as they are parallel, this n cap is perpendicular to this plane. Now, as these two planes are parallel, so this n cap vector also perpendicular to this imaginary plane also, which contains our point from which we are going to find the distance of this plane. So now we have got a unit normal vector perpendicular to this plane. Also, this given point, suppose this given point has position vector with respect to this origin, that Cartesian coordinate system is a vector. Now we have in our hand that this plane passing through a given point and perpendicular to a given vector. Again we are going to use the concept what we have discussed in our previous lecture, which I illustrated by these mathematical models. You just go through the playlist and you can easily get the thumbnail with these models. So you just go through this lecture, then you can understand what I am telling about. So this plane is passing through a given point with position vector a vector, and normal vector to this plane is n cap. So what is the equation of this imaginary plane? R vector minus a vector dot n cap equal to 0. So now if we just simplify this r vector minus a vector dot n cap equal to 0, we have in our hand r vector dot a vector equal to a vector dot n cap. So if we compare this equation with this plane with r vector dot n cap equal to d, then d is here in our hand, we get d equal to a vector dot n cap. Now this d is the distance of this imaginary plane from the origin which contains the required point. So we have in our hand this much distance. So distance of this point in the space from the origin we have in our hand, which is a vector dot n cap. Also we have the distance of origin from this plane, which is d. So what is the required distance? That is from this point to this plane? Obviously d minus this much distance. So we have to subtract. So d minus a vector dot n cap is the required distance of this point in the space from this given plane. That is the main trick behind this whole theory. So now we are done with our beautiful mathematical models, and now we are going to see the whole proof in our blackboard. So go to the blackboard. So now we are moving to our blackboard. Okay, so first we will draw the diagrams. This on x-axis, y-axis and z-axis. Name this as origin O, this is x, this is y and this is z. Suppose in white color this is the given plane. This given plane is denoted by white color in the diagram. Now in red color we are denoting this point. Now this point, say red point, and this is the white color in the diagram, this is the plane, so we have to find the distance between them. So before finding distance, first we draw another plane containing this point, red point P, say in blue color. So now, and also this blue plane and white plane are parallel to each other. So let the equation of the given plane phi 1 say is r vector dot n cap equal to d. So therefore this much distance is d from the origin, and also n cap is the normal vector to this white plane. So as this blue plane and the white plane are parallel to each other, so this n cap is also perpendicular to this plane, blue plane. Now let us consider that let the given point P has position vector A vector. Okay, in diagram A vector. Now as the plane in blue color is passing through the point with position vector A vector and is perpendicular to the vector n cap. So by our previous lecture number 23, where we have used this beautiful wooden model, that is equation of a plane perpendicular to a given vector and passing through a given point is r vector minus a vector dot n vector equal to 0. So therefore the equation of the plane in blue color, say this plane is named as pi 1, pi 2, this one is pi 1. Okay, equation of the plane blue, plane pi 2 is r vector minus a vector dot n cap equal to 0. I think up to this you have understood very clearly. So after simplifying, r vector dot n cap equal to a vector dot n cap. So comparing this with r vector dot n cap equal to d dashed, that is the equation of a plane in normal form, what we have discussed in lecture number 20. We get the distance of this plane in blue color from the origin is a vector dot n cap. So here up to this, say this point is Q. We get OQ equal to distance, perpendicular distance, obviously perpendicular distance, undo equal to perpendicular distance of plane pi 2 from origin. Next page equal to OQ, say next page equal to OQ equal to, say previous page, a vector dot n cap, a vector dot n cap. Now see previous page, this ON, say this point is n, ON equal to D, but distance, not distance, perpendicular distance, but perpendicular distance of plane pi 1 from origin, pi 1 say, equal to ON equal to D. So now this much distance ON equal to D and OQ equal to a vector dot n cap. So our required distance is what? That is QN. That is the distance of the point P from the plane pi 1. So the required distance, therefore the required distance of the given point P from the given plane, undo, given plane pi 1 is ON minus OP, I think previous way, ON minus OQ minus OQ. So D minus OQ means a vector dot n cap magnitude. So it can be written as a vector dot n cap minus D also. It is within magnitude because we have to take the positive value as it is a distance. So this is the vector form. So this is the required blue vector form. Now if the equation is given, equation of the plane pi 1 is given as r vector dot capital N vector dot equal to D, that is where n vector is not a unit normal vector, it is a just normal vector to the plane. Then what is the form we will take we will see in the next page. If the equation, you can say it as note, if the equation of the plane pi 1 be r vector dot n vector equal to D, then the required distance is, say it is as eraser capital D. Required distance will be what? A vector dot n vector minus D. See previous page. A vector dot n vector minus D. But here we have to divide it with the magnitude of n vector, because in that place we have to get the unit normal vector. So how to get the unit normal vector? By dividing n vector by its magnitude. So equal to a vector dot n vector minus D magnitude by n vector magnitude. Here we can derive the Cartesian form also. We just see in the next page. So let next page. Cartesian form of distance. Because while solving problem, we need any one of them, either Cartesian form or vector form. Accordingly and wisely, according to the problem, we will use the forms. Okay. So now let direction ratios of capital N vector are A, B, C. Therefore, N vector equal to A I cap plus B j cap plus C k cap. Also, let the point given point has coordinates x1, y1, z1. Therefore, given point is what? It was I think P. In the diagram, it is a P with position vector A vector. So P. Therefore, A vector equal to x1 I cap y1 plus y1 j cap plus z1 k cap. So therefore, we just simply put the values in this equation. A vector dot n vector equal to what? A vector dot n vector. Here see, A vector is this, n vector is this. So A x1 plus B y1 plus C z1. Next page, previous page, minus D magnitude by n vector magnitude. So root, my handwriting is very bad. Okay, so root A square plus B square plus C square, take whole magnitude unit. So this is the distance of the point given P from the given plane in Cartesian form. So now we are going to see one application of this theory. So it will be very useful. Different types of problem may come, and while solving this type of problems, you have to use this Cartesian form or vector form. So one application of the theory. Find the solution. Now, right. So here the point is 3 minus 2, 1, and the plane is 2x minus y plus 2z plus 3 equal to 0. So therefore, the required distance is just satisfy this equation of the plane with the point 2 into 3 minus y into minus 2 plus 2 into z 1 plus 3 by root 4 plus 1 square. Here I will just break down each step. Here 2 square means capital A square plus minus 1 square means capital B square plus 2 square means capital C square equal to what? So equal to 6 plus 2 plus 2 plus 3. Here root 4 plus 1 plus 4. So equal to 6 plus 2, 8, 10, 13 by 4 plus 4, 8 plus 1, 9, so 3. So unit, 13 by 3 unit. So we are done. So we have reached at the end of today's video. Hope you have enjoyed this video a lot. It is a very interesting concept of three-dimensional geometry. If you have any doubt, please watch the video again. I hope you can understand it very easily. Especially you just see the portion of this video where I have used the teaching learning material. That is the models I have used. These two planes and this tripod as the models I have used. So you just go through this video once again, you will understand everything very easily. Nothing is there. Thank you.